In this problem, we're going to try and calculate the height of a mountain. In traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle of elevation is 9 degrees. Approximate the height of the mountain. So I'm gonna first draw a picture of this mountain. So I've got this mountain, okay. Here. I know you've already got, that looks more like a volcano. I got a mountain. I can't even draw a mountain right now. A mountain, there's a mountain. And you're drawing on flat land. So you're driving on flat land. And the angle of elevation to the top of the mountain, there we go. The angle of elevation to the top of the mountain is 3.5 degrees. So 3.5 degrees. So I've got this right triangle that has an acute angle of 3.5 degrees. And I know that I'm going to be looking for the height of the mountain. So I'm going to color code that and call it H. Now 13 miles later, when I'm closer to the mountain, we'll say that this is 13 miles. So 13 miles later, I'm closer to the mountain, and the angle of elevation is now 9 degrees. I still have a height of a mountain being H, so the height of the mountain has not changed. Now what I have here is I have two triangles. I've got this larger triangle in green, which is a right triangle that has an acute angle of 3.5 degrees. And then I've got the smaller right triangle, still another right triangle, whose acute angle is 9 degrees. And both triangles share the same height. So one of their legs is the same. I'm going to draw these triangles separately so that you can see. And they're not going to be to scale because I want to draw them side by side. So this is 3.5 degrees. And then this one is going to be 9 degrees. Same height, but this one's going to be 9 degrees. So its bottom leg is going to be a little bit shorter. Okay. So this is still my height. This is my height. This long leg right here that goes with that green triangle, that's this side right here. So part of this length is 13 miles. This side right here, and let me color code it for you so that you can see. This side right here, this red side, is this side. So this bottom part here, there's my 13 miles. But then I also have this red part that goes along with it. So I don't quite know two sides on either triangle. I do know that I can call this red side X. So I'll have X for that, and then I'm going to bring this 13. So this whole length would be 13 plus X. I'm going to create an equation, a trig equation for each triangle. And then because they're related, they're part of the same bigger triangle, right? This purple one is inside this bigger triangle and they share that same side. I'm going to have a relationship there that I'll be able to work algebraically with. So I draw an arrow going to the opposite side. So the height is going to be the opposite side, and then the other leg is the adjacent side. So opposite, adjacent, that's tangent. So the tangent of 3.5 degrees is equal to H over 13 plus X. Now I'm going to go over the triangle on the right, and I'm going to do the same thing. I've got opposite, and I've got adjacent. That's tangent as well. That's the tangent of 9 degrees, though, and that's equal to H over X. Now I'm going to consider these two equations together. They both have this H. So I'm going to solve them both for H. h is equal to, in this case, I'm going to have 13 plus x times the tangent of 3.5 degrees. And the tangent of 3.5 degrees is just some decimal number. The one on the right, I've got h equals x times the tangent of 9 degrees. Now they both equal h, so they're both going to equal each other. So I'm going to take 13 plus x all times the tangent of 3.5 degrees, which is going to involve the distributive property, equals x times the tangent of 9 degrees. I'm going to distribute this tangent of 3.5 degrees to both terms in the binomial. So I'll have 13 times the tangent of 3.5 degrees plus x times the tangent of 3.5 degrees equals x times the tangent of 9 degrees. Now, in order to solve for x, I need to collect all the x's on the same side of the equation. So I'm going to keep 13 tangent of 3.5 degrees on the left-hand side, and I'm going to subtract over x times the tangent of 3.5 degrees. That's going to allow me to factor out an x. And then divide both sides by that difference. So I'm going to have x is going to equal all of this. So after I do all of this algebra work, I've almost forgotten what the problem is even asking and what I'm dealing with. So I'm going to write equals x so I don't have to rewrite the whole darn thing all over again. Now, what was it asking for? It was asking for the height of the mountain. And the height of the mountain is h. And over here, I got h equals x times the tangent 9 degrees. But I didn't know what x was. But now I do know what x is. So when I'm solving for h, whatever this value is, whatever this value turns out to be, I'm just going to multiply it by the tangent of 9 degrees. I'm going to put it in for x, which is being multiplied by the tangent of 9 degrees. So whatever this value is, I'll multiply by the tangent of 9 degrees. So I'm going to do all of this in my calculator right now. So I'm going to show you. And I wish I had a screen and a screen. I think I do have a screen and a screen. I just have to figure out how it works. And I might do that the next time, just for fun, for maybe another video. Okay, let's go to my camera. And I had 13, not list, 13, actually I'm going to make it the fraction that it is, 13, was it 13? It was 13, times the tangent of 3.5 degrees, and I'm still in degree mode, so that's good, over the tangent of 9 degrees minus the tangent of 3.5 degrees. And I'm not sure that I need the parentheses there, but it made me feel better. And then I press enter, and I get 8.178. So remember, that stood for the number of miles that were left between you and the mountain. So after you drove 13 miles, you had 8.178 miles left before you hit that mountain. We're going to take that and we're going to multiply it by the tangent of 9 degrees. And I get 1.295 miles. 1.295 miles. So let's go back here to our screen and just show you what we did. So this was approximately 8.178 miles. So this green circle here was about 8.178 miles, and I took that and I multiplied it by the tangent of 9 degrees so that I can get h. And h approximately 1.295. And then our distance is measured in miles because that's what they were talking about in the problem. So that's how we're going to label our answer. And in the next video, we'll do our last video with the inclined plane.